Hello everyone. In this video we're going to be solving a polynomial system. We have x squared equals 13x plus 4y and y squared equals 4x plus 13y. We have two equations and we're going to be solving for x and y values. I'll be presenting two methods, and sorry about the first one, it's a little painful. So I'm going to number the equations. This is number 1 and this is number 2. And let's go ahead and talk about our first method first. Did I say I'll be presenting two methods? I don't know. Anyways, this is the first method. From equation number 1, we get 4y equals x squared minus 13x. And I'm going to divide both sides by 4 to get y in terms of x. Great. So this is something that we're going to be subbing in equation number 2. This one I'm going to be substituting. Okay, what's the second equation? Y squared equals 4x plus 13y. Replace y with x squared minus 13x over 4 here and here. So I do get a quartic equation, apologies, from here. And if you expand it without making a common denominator, this is what it looks like. It's going to look like this: x to the 4th power divided by 16 minus 13 x to the 3rd divided by 8 plus 117 x squared divided by 16 plus 153 x divided by 4 equals 0. First of all, I want you to notice a couple things. Making a common denominator shouldn't be too hard. Second, x can be factored out, which means x equals 0 is a solution. Nice. Let's go and multiply both sides by 16. Hocus pocus, abracadabra. We get x to the 4th minus 26x cubed plus 117x squared plus 612x equals 0. And guess what? We keep saying this all the time. X can be factored out, and we're going to end up with a cubic, which again is not very easy to solve, but if you're looking for integer solutions, you could use the rational root theorem, trial and error, but I'm going to spare you the trouble and give you the solutions. So this quartic equation can be factored as x times x plus 3 times x minus 12 times x minus 17. And set it equal to 0, you're going to get all the solutions. First solution is x equals 0. The second one is x equals negative 3. And then we got x equals 12. And then we got x equals 17. Let's go ahead and find the corresponding y values. And you'll be surprised a little bit. If x is 0, y is also 0. Because if you pay attention to the original equations, you're going to notice that, right? 0, 0 is going to work. And then if x is equal to negative 3, y is going to become 12. And because of the symmetry, if x is 12, then y is going to be negative 3. Because x and y are completely interchangeable. So what happens to 17? There is no other pair that matches it. So the values are going to be equal. Yes, that's right. That's when the x and y values are equal to each other. Which is kind of interesting because that kind of ties nicely into the second method. So for my second method, obviously, I'm going to use a smarter approach. But sometimes the reason why I introduce more than one method is, first of all, people look at problems differently, and it's okay to use any method you like. Some people like a method better than others. Some people are stronger at certain things. So I want to present more than one method because it's also important. Sometimes one of the methods do not work in general, because some of these methods are very special, and I know it doesn't work all the time. Anyways, notice the symmetry about this system. Let me rewrite my system. Notice the symmetry here. We're going to take advantage of that. Let's go ahead and subtract these two equations. Notice that we have 13 in both equations and 4 in both of them. So they kind of nicely switch around. If you subtract these equations, you get x squared minus y squared equals 13x minus 4x. So you can basically, you can do the following. How about this? 13x plus 4y. From that, subtract the second one so you don't get confused. Sometimes I do get confused. X squared minus y squared is equal to, now 13x minus 4x is equal to 9x. 4y minus 13y is equal to negative 9y. This is really cool because the left-hand side is factorable and right-hand side has the same factor. But do not cancel anything out because you're going to lose solutions big time. And you can tell from here that y equals x works because we've noticed that with the first method if you've seen the first method. So now, instead of canceling out terms, I'm going to put everything on the same side. So a good strategy is put everything on the same side and set the whole thing equal to 0. Nice. Now x minus y is a common factor. Take it out. And then you end up with x plus y minus 9. And from here, from zero product property, I don't know why they call it that way. It's kind of like a weird name, but anyways, if a product is 0, then you check each factor and want it to be 0. First one, x minus y equals 0 gives us x equals y. Okay. And this is really nice because we kind of got it with the first method, but it wasn't until after we found the solutions, right? We didn't know ahead of time that x equals y. This would be helpful information. By the way, you don't have to use both of these equations, even though you can, because when you replace y with x, you're going to get the same thing. Like, you don't really need the same thing twice. So I'm going to go ahead and just ignore the second equation now. Okay, so y equals x. Let's go ahead and replace y with x. So I get the following. Now let's go ahead and add 13 plus 4, which is 17. Again, do not divide both sides by x or cancel it out because you're going to lose solutions. Instead, put everything on the same side and always factor. Okay, x out, we get the following. From here, we get two solutions for x equals y. Remember, we got these values before. So x equals 0, but since y equals x, this means y equals 0. Or x equals 17 and y equals 17. So this kind of gave us the, sort of obvious solutions where y is equal to x. Because of symmetry, we could have deduced that without going through all these steps. But there's another piece to it. We also have x plus y minus 9 equal to 0, which indicates the following. X plus y minus 9 equals 0 means x plus y is equal to 9. Cool. How am I going to use this information? Let's go ahead and rewrite the equations. How about the first one only? Okay, I keep using the first one. You can replace y with 9 minus x. Yay! I can use substitution one more time. This is really cool. Now replace y with that. You're going to get 4 times 9 minus x. And this is going to give you x squared equals 13x plus 36 minus 4x. And this is going to give you negative 9x, but it's going to be positive 9x on the left-hand side and negative 36 on the left-hand side. And now you're looking for two numbers whose product is negative 36 and whose sum is 9. And those numbers are, right? From here, you're going to get the following. X minus, let's see, okay. X equals 13x. I hope I didn't make a mistake because something doesn't look right to me. Let me go ahead and double check real quick. So we got x plus y equals 9. Y equals 9 minus x. And 36 minus 4x. And we replace y with that. And now we get x squared equals 9x plus 36. Okay, it should be negative 9x because I'm bringing the x. Okay, let me do the following. X squared equals 9x plus 36. I skipped that step and I confused myself. So it should be like this. And now I'm looking for two numbers. Negative 12 and 3 are the numbers I'm looking for. To keep a long story short, x minus 12 and x plus 3 equals 0. And guess what? From here we get x equals 12. Since their sum is 9, y is negative 3. Or x equals negative 3 and their sum is 9. So y is equal to 12. And this brings us to the end of this video. Thank you for watching. I hope you enjoyed. Please let me know. Don't forget to comment, like, and subscribe. I'll see you tomorrow with another video. Until then, be safe, take care, and bye-bye.